All right, welcome back. And this unit talks about polygons and regular polygons. We've been talking about polygons for a while. A polygon is simply a multi-sided closed figure. The sides are made up of segments that can only intersect at their endpoints, the smallest one being three-sided, a triangle, then quadrilateral, and so on. So we have a couple examples of what makes a polygon and other examples that are not polygons. Notice the circle and even the shape that is part of a circle. They do not fit the definition of a polygon because they are not made of only segments, and specifically segments that meet at their endpoints. We also have an example right here a picture that we've seen in the past when we've treated it as two triangles. If we say it's two triangles, then yes, each triangle is a polygon, but as a single shape, it just does not fit the definition. So that is not a polygon, although we could say it is made up of two different polygons that happen to touch each other. We have some vocabulary, as usual, convex and concave. So a convex polygon, we can simplify that as all the vertices point out. If you think about each corner as an angle, the two sides come together to make a point. If it was pointing outward, it is convex. If it's pointing inward, even just one of them, it would be a concave. So I like to think that as a cave goes into the side of the mountain. In this case, a concave polygon has at least one vertex that points inward, where convex means they all point outward. So a couple examples of convex and concave. You can see in convex, if we think about any corner, they point out. So if it was an arrow, it's pointing out, where concave has at least one that points inward. So again, just some examples. We also have some vocabulary for the names of these shapes or classifying these polygons based on the number of sides, the smallest one being a triangle, the next being a quadrilateral, and it goes on from there. So you can certainly read the next two slides and get very familiar with the names of these polygons. Now, they've all got names, but we're only going to go up to a certain point. So on our first slide here, it goes up to 7, a heptagon. On the next slide, we take it up to 12 as a dodecagon. And after that, while they all do have names, we tend to just call them n-gons to make it simpler. N meaning the number of sides. So if it was 14 sides, a 14-gon. 32 sides is a 32-gon, and so on. They absolutely do all have names, but we're not required to know them all beyond a dodecagon. So let's get into some of the work that we perform with polygons, and then we're also going to talk about regular polygons. So the first thing we do, this is true for all convex polygons. We don't really work much at this level with concave polygons, but we need to identify them. All of our work at this level is going to be with convex polygons. And just like triangles, the angles add to 180, and parallelograms and trapezoids, the angles add to 360. Well, we can determine the sum of the interior angles for any convex polygon. So this slide kind of explains how we go about it, but ultimately we can just come up with a simple formula. And that formula is S equals n minus 2 times 180. N is the number of sides. S is the sum of the interior angles. So if this was a triangle, we would plug in 3 for n, and 3 minus 2 is 1. 1 times 180, so the sum of the angles is 180. So we're going to do a little practice with that. Not going to do every question, just a couple to show you. So an octagon means 8 sides. So the sum of the interior angles is 8 minus 2 times 180. So 8 minus 2 is obviously 6 times 180, and we get 1080 degrees for the sum of the interior angles. A 14gon means 14 sides. So the sum equals number of sides minus 2 times 180. So the sum of the interior angles, 12 times 180, equals 2,160 degrees. Straightforward formula. Sum equals n minus 2 times 180. We can use that formula in reverse. Remember our formula, sum equals n minus 2 times 180. Well, make that a little bit neater. Sometimes we know the sum of the angles. For example, we were given in number 2, 540 degrees. That's the sum of the angles, n minus 2 times 180. So we're going to do some algebra here. You can do this by distributing the 180 and then solving for n, or you can divide by 180. So remembering our algebra is going to be very helpful. That gives us a 3 equals n minus 2, and minus 2, add 2, 5 equals n. So number of sides is n. But what is the name of this polygon? It is a pentagon. And we'll do another one. I'm going to bring it over here on the left. Let's do number 3. The sum of the angles equals n minus 2 times 180. Again, we can divide by 180. If you prefer distributing, that's the same. We're going to get the same results. 180n minus 360. We're going to add 360. So we have 3,240 plus 360 is 3,600. And now we'll divide by 180 to isolate the variable. And we get 20. So this is a 20gon. Just showing you different algebraic approaches, but the problems are exactly the same. We talked about the sum of the interior angles. Let's talk about the sum of the exterior angles. The sum of the exterior angles for all convex polygons will always be 360. So the sum of the exterior angles of any convex polygon is 360. Just like in triangles, the exterior angle is created by extending the side. So we can see here that the interior and the exterior right next to it are supplementary. They will add to 180. And this information can be used a few different ways. We also have regular polygons. Regular polygons mean that all of the sides are congruent, all of the interior angles are congruent, and all of the exterior angles are congruent. So they're perfectly symmetrical, they have perfect balance. Again, we learned about number of sides, interior angle, some of the interior and some of the exterior. Now we're saying all of the sides are congruent, all of the interior angles are congruent, all of the exterior angles are congruent. So we've got a couple formulas here that are important to us. The sum of the interior, the sum of the exterior will always be 360, and an interior plus an exterior equals 180. Those are the formulas that we're going to need. As an example, at the bottom of the slide, we can see a regular hexagon. And it's important to note that the number of sides, in this case 6, is the same as the number of interior angles, which is the same as the number of exterior angles. And in fact, if we split it by drawing in all the diagonals, it's the same as the number of isosceles triangles. So we have a lot of uniformity, a lot of symmetry, a lot of repetition. Let's see what we're asked to do here. We're asked to find the measurement each interior angle. So not the sum, only one of them. Well, we have a hexagon. That's 6 sides. So if we find the sum of the interior angles, 6 minus 2. So the sum 4 times 180 is 720 degrees. This is the sum. We want 1. So we're going to take our 720 and divide by 6. The number of sides is equal to the number of angles. So 720 divided by 6. Each interior angle equals 120 degrees. Let's try that again. A nonagon is 9 sides. So the sum of the interior angles, 9 minus 2 times 180, the sum of the interior angles is 1,260 degrees. Again, this is the sum of the interior angles. We want 1, so 1,260 divided by 9. Each interior angle is 140 degrees. So what did we do here? We found the sum and then divide by how many there are. We've got various ways to do this. This is one way. If we wanted to, we can find out the exterior and then switch to the interior. So it's just another way to do it. If we have our formulas available to us, we can figure out how to do it different ways. So this is 14 sides. which means there's 14 interior angles. There's also 14 exterior angles. Well, since the sum of the exterior equals 360, I can divide by the number of angles and find out each exterior angle. Each exterior angle equals 25.7 degrees. And now, since we know an interior plus an exterior equals 180, we can find the interior by subtracting it from 180. So 180 minus 25.7 tells us that the interior is 154.3 degrees. So we can approach this a few different ways. Given the measure of an exterior, find the number of sides of that regular polygon. So again, this is an exterior angle. The sum of the exterior angles is always 360. If I can write it, is always 360 degrees. If we divide by the number of angles, then that would tell us how many there are. Or, well, if the sum is 360 and we divide by the number of angles, that would tell us each exterior angle. If we take the sum and divide by each angle, that would tell us the number of angles. So 360 divided by 90 tells me that there are 4 exterior angles, which means there's 4 sides, which means this is a quadrilateral. (360 degrees divided by 8 degrees tells us there are 45 exterior angles, which means has 45 sides, which means it's called a 45gon. And just to do the one more, I'll bring it up here on the left. 360 divided by 30 tells me that there are 12 sides. So this is a dodecagon. Find the measure of an interior and exterior. We've kind of done this problem already. We've got 2 different ways to do it. Option 1, 10 sides. So we can find the sum of the interior is 1440. Each interior, 1440 divided by 10 because there are 10 interior angles. Each exterior 144 plus the exterior equals 180, and we can find that the exterior angle equals 36 degrees. We can follow option 2. Instead of going for the sum of the interior, we can work with the sum of the exterior. Because we already know it's 360. So that means each exterior angle we divide by the number of angles. So 360 divided by 21 is 17, let's see, 0.14, so we'll go with 0.1. And then for each interior, well, the interior plus the exterior, 17.1, equals 180. So that means the interior is 162.9 degrees. So it's the same 3 steps, except if we start with exterior, we don't have to calculate it. By definition, it is, or by rule, it is 360 degrees. And our last set of practice problems, we are given an interior. So this is one interior angle. And we're asked to figure out the number of sides and name the polygon. Well, the only thing we can do with one interior is find the exterior. That's the only formula we have that uses one interior. So 120 plus the exterior equals 180, and the exterior equals 60. But we know the sum of the exterior equals 360. So 360 divided by 60 tells us that there are 6 exterior angles. That means there's 6 sides. That means this is a hexagon. So let's try that again. This is an interior angle. Interior plus exterior equals 180. So 135 plus the exterior equals 180. The exterior equals 45 degrees. The sum of the exterior is always 360. So if we divide by each angle, that's going to tell us that there are 8 exterior angles, which means there are 8 sides, which means we have an octagon. So there's 3 main formulas for us to focus on. The sum of the interior, n minus 2 equals 180. The sum of the exterior is always 360. And an interior plus an exterior equals 180. So it just depends which we're working with. If we only know one interior, we've only got one formula. If we know the exterior, we can get the interior, or we can figure out how many there are, because the total for the exterior is 360. And then, of course, if we know the number of sides or the sum of the interior, we've got one formula. All right, let's do some practice with it.